A very warm welcome to one and all present here. Today, we LOK aviators are thrilled to showcase our collision avoidance quadcopter to the public. My name is Lavleen Kala, and today I'll be presenting the robotics project alongside my teammates Karthik and Om. Together, we have worked tirelessly to bring you an innovative quadcopter design. Let's dive into the details. Our goal was to control the drone with the remote, making them self balance, adding collision avoidance, and incorporating a surveillance camera. Our goal is to enhance drone's functionality and performances. We developed a self balancing mechanism to maintain stability during flight, ensuring precise control. To address safety concerns, we integrated collision avoidance technology. The drone uses ultrasonic sensors and microcontrollers to detect obstacles and navigate around them with precision. For surveillance purposes, we added a high resolution camera with video streaming capabilities. This enables applications in security, monitoring, and certain rescue operations. In summary, our project enhances control, stability, and safety by implementing self balance, collision avoidance, and surveillance capabilities. Moving on to the collision avoidance system, our aim was to design and implement a system that allows the quadcopter to autonomously avoid obstacles and maintain stable flight. To achieve this, we integrated a Pixhawk flight controller and Arduino Uno for sensor data processing. We utilized two HC-SR04 ultrasonic sensors for obstacle detection. Our objectives also included evaluating the performance and effectiveness of the collision avoidance system.
Traditional quadcopters often lack the ability to detect and avoid obstacles, posing safety risks. To address this issue, we developed a collision avoidance system that utilizes sensors and intelligent algorithms to detect and navigate around obstacles in real time. Throughout our project, we followed key guidelines to ensure success. Maintaining a safe flying distance from obstacles allows for proper detection and reaction time. We also considered the limitation of the HCSR04 sensor, such as range, accuracy. It's important to ensure that the quadcopter remains within the maximum payload capacity and flight time of the chosen components. Additionally, observing local aviation regulations and a safety guidelines is crucial during testing and operations. The task at hand involves several components and steps of integrating sensors, flight controller, and developing algorithms for obstacle detection and avoidance. Here is breakdown of process. Sensor integration. Connect HCSR04 sensor to Arduino Uno. This involves physically connecting the ultrasonic sensor to Arduino Uno, ensuring proper wiring and proper supply. Configure sensor. Program the Arduino Uno to communicate with the HCSR00 sensor, configuring them to send and receive ultrasonic signal and measure distance accurately. Flight controller integration. Interface the Pixel flight controller. Establish a communication between Arduino Uno and the Pixel flight controller to enable data exchange and communication. Data exchange. Implement a protocol and communication interface to transfer sensor data and flight control command between the Arduino Uno and Pixel flight controller. Algorithm development. Design intelligent algorithms to process sensor data and make real-time decisions for obstacle avoidance. Testing and optimization. Conduct various testing to evaluate the system performance and make necessary improvements.
Thank you, Karthik. So let's start with our design and implementation. So the material used in our quadcopter are Pixhawk flight controller, Arduino Uno microcontroller for sensing the sensor's data, 2x HCSR04 ultrasonic sensor for detecting objects, 4x BLDC 1000 kilovolt motors, 4 30 ampere ASC which are electronic speed controllers to control motor speed, F450 quadcopter frame and a LiPo battery. Remember to buy all the components from Delhi offline market, which is Lajpat Rai market. So let us understand the circuit diagram of both our quadcopters which we made. One with Arduino Uno and Pixhawk and one with purely Arduino Uno. In the Pixhawk one, you can see the Arduino Uno is receiving sensors data and Arduino is connected to telemetry 1 of Pixhawk, in which it uses interrupt programming for interrupting the Pixhawk work and avoiding the objects whenever it comes nearby to them. In the second diagram, you can see the purely Arduino Uno made drone circuit diagram, in which you can see all the motors and their ESCs are respectively connected to Arduino Uno, and Arduino Uno is further connected to the flight receiver. Now the code we used for the collision avoidance in our main quadcopter is provided here, and it is also provided in the link given in the description. It is a GitHub repository link in which you can see the sensors which we have included in front and backwards. It uses interrupt programming, and whenever it detects objects under 70 meters, which we have set in the max distance, as you can see, it detects the object and moves in the opposite direction. You can also check out the Arduino Uno code which we have provided, which is only self-balance.
So hi guys, in this video, as we can see that Om is calibrating the drone's gyroscope by rotating the drone in all directions, and by doing so he is telling the drone which side is which. And in this video, Karthik is calibrating the drone's gyroscope's 3 axes, that is X, Y, Z. He is doing so by rotating it along all the sides. And as you can see that Om is guiding Karthik using an app called Mission Planner. And Karthik is rotating the drone along all axes. And then this is the live streaming video footage of our drone, which can be seen using anyone's phone who has access to the ESP32 camera. This is the footage of our drone's first flight using the Arduino as the microcontroller, which didn't happen well. This is another one of our tries using Arduino Uno, again which didn't go as planned. This is the flight of our drone using Pixhawk as the microcontroller, and as you can see, it was the drone's first official flight. And here we are testing the drone finally in an outdoor environment. As you can see, the drone is doing all of its movements, and we have tied the drone using a rope in order to make sure that it flies in a controlled environment and doesn't go out of range. And as you can see that in this video, that the drone is finally flying really well in a controlled motion upon all the commands.
Last but not the least, let us come to the conclusion. What went well? More of everything worked out as exactly as we wanted. It's just we have to use Pixar Flight Controller along with Arduino Uno for providing a stable flight with our quadcopter. What didn't go well? We expected to make a purely Arduino Uno drone, but it failed to provide equal amount of powers to all the motors simultaneously to self-balance the quadcopter in a proper manner. So main action items of our quadcopters are real-time live streaming of 720p video in anyone's phones which have ESP32 integrated with it, real-time collision avoidance which detects objects within 70 meters and moves in the opposite direction, and lastly, it always self-balance. Folks, we are not done yet. We will come with more additions to our quadcopter like automatic delivery system and so on. Thank you for watching. Have a great day ahead.